Okay, now let's look at the definition of the second, which is a unit to measure time, one of the dimensions we're interested in. Okay, so now we'll define the second very precisely because measurements nowadays are so accurate that you need this precise definition. All right, so to the second is, okay, let's read the definition of the second. The SI unit for the time is the second, defined as 9,192,631,770 times the period of a specific radiation from cesium. All right, so let's see what that means. Okay, now let me go to a app for that. Oops. Okay, so I will go to my website, links, simulations, and then we'll go to the electromagnetic wave. Okay. All right, so imagine that you are getting light from a cesium atom. We're looking at a particular frequency, and here's the electromagnetic wave coming at you. Okay, so we'll start this, and this is the electric field. Oops. Yeah. Here's the electric field, here's the magnetic field, and the beam of light is going in this direction. Now, if you were standing there and looking at the electric field, the E field is oscillating back and forth, up and down along the y-axis, and the B field is oscillating along the z-axis. The period is the time for one oscillation. And when 9 billion and change of these wavelengths pass you, 1 second has passed. And that's the definition of the second. Okay, so that's what we mean by that. So when 9 billion 192 million and change wavelengths pass you, 1 second has elapsed. So that's the definition of the second. Now here's an atomic clock, and atomic clocks such as this one can keep time to a precision of better than one microsecond per year. So this doesn't go off. This clock goes off less than 1 microsecond per year. Okay, so that's the definition of the second now. The other basic quantity we'll be dealing with is length. The SI unit for length is a meter, and here's the precise definition of a meter. So it's the distance light travels in 1/300 millionth of a second, roughly. Okay, the speed of light in physics is constant, and it's the same everywhere, no matter where in the universe you would be. And so this definition, along with the definition of the second, would be anybody anywhere in the universe can understand this. So the distance traveled by light in 1/300 millionth of a second. Mass is the third basic quantity we'll be dealing with. The SI unit for mass is the kilogram. And back in the old days, they put a lump of matter in somewhere in Paris and called that the kilogram. And if you weigh other masses against it, and then you have a copy of your own kilogram. But this mass can change over time ever so slightly because of chemical reactions or whatnot. And so Now, the latest definition of the mass is as follows. The kilogram is defined by taking the Planck constant. The Planck constant is a fundamental constant, and this we say, okay, the value, we say that the value of Planck's constant is precisely this, 6.62 times 10 to the minus 34 joule second, and joule second is kilograms meter square per second. Now we've already defined meters and seconds. So if you want 1 kilogram, all you do is uh, take take the value of the Planck's constant, divided by meter squared times a second, and that'll give you 1 kilogram. Okay, so that's how you define the kilogram. Um, so here's a very precise definition of a kilogram. Um, okay, so now the next thing we want to